Hi guys, welcome. This is week 5, and we're going to be covering lesson 91, 92, and 93. All right. So lesson 91, we're looking at the effect of scaling on perimeter area and volume. So this is really the reference that you can put on your reference sheet. I think I've allowed you to put it on there already, but it's a good helpful reminder when we have a scale factor. Again, scale factor can make something larger if it's greater than 1. It can make it smaller if it's less than 1. And how that affects the perimeter area and volume are as follows. The perimeter will go up by the scale factor. The area will go up by the scale factor squared. And then if it's volume, it'll go up by the scale factor cubed, or to the power of 3. So, and we can look through this mural. He had an original canvas painting. He wanted to do a wall that was a scale factor of 10. So 10 times, he bought 10 times as much paint, when really he needed 100 times as much paint and supplies, because the area of the wall was 100 times that of the canvas painting, because the scale factor was 10. But we'll look at a more simplified version. All right, so let's look here. So let's say this is a 1 by 1 by 1 by 1 square. Okay, this one, we had a scale factor of 2. So SF, scale factor. Okay, perimeter of this one, pretty simple. 1 times 4, it's 4. This one, okay, 2 times 4, which is 8. So 4 times our scale factor, 2 equals 8. So the perimeter just went up by the scale factor. Now the area of this one, 1 times 1, 1 square units. The area of this one, 2 times 2 is 4. So this one was 1, but we didn't multiply it by 2. We multiplied it by 2 squared, because really it's 2 times 2 to give us 4. So the 2 dimensions is why the exponent is 2. So we did the scale factor squared, so it's 4 times greater. And then if we were to look at that in this, okay, as a cube, I know these distances, just for time's sake, I'm not going to go in and redraw all of them, but this is a 1 by 1 by 1 cube, and then this is a 2 by 2 by 2 cube. Okay, scale factor, again, is 2. A volume of this, 1 times 1 times 1, 1 cubic unit. Volume of this one, 2 times 2 times 2 is 8 cubic units. So it went up by the scale factor, not just the scale factor squared, the scale factor to the power of 3. So the scale factor was 2. So 2 to the power of 3, that means the volume is 8 times bigger than the original. Okay, so it's the scale factor for perimeter, scale factor squared for area or surface area, lateral surface area, and then anything 3-dimensional, again, 1-dimensional, exponent's 1. 2-dimensional, exponent's 2. 3-dimensional, the exponent is 3. Okay, for this one, Irene works with a stained glass. She wants to make a replica of a stained glass window. Her replica will be related to the original window by a scale factor of 1/3. So it's going to be going down. It just keeps kicking me out. I want to make sure we get this. All right. So it's going to be going down in size. It's 1/3. The original was 3,456 square inches, and the perimeter is 240 inches. And what's going to be the area and perimeter of the new one? It's going to be smaller, but the scale factor was 1/3, so the area is going to be 1/9 of the original, because 1/3 squared is 1/9, so it's going to be 384 square inches, whereas the perimeter, one-dimensional, be 1/3 times 240, which is going to give us 80. So just pay attention. If you remember that chart up above of scale factor in relation to perimeter, area, and volume, then that really will be all you need to know. You can go in and redraw things and try and scale them and this and that, but if you remember the rule, it's going to make it a lot easier. So let's look at this one. We have 4 1-inch cubes. So 1, 2, 3, and then a fourth one underneath that we can't see. And we double the dimensions. So how many of these 1 by 1 by 1 cubes are we going to need? Well, the scale factor is, we're doubling, so it's 2. Okay, so now instead of 1 by 1 by 1, we're going to have 2 by 2 by 2. So down here, we're going to now have 1, 2, 3, 4, 5, 6, 7, 8. We're going to have that 4 times. So we're going to have 32. So 32 is 4 times bigger than 8. So our scale factor, is 8 times bigger than 4. So we had 4 originally here. We have 32 here. So our scale factor was 2. We're talking about volume, so it's 3-dimensional. So that's where we get the exponent of 3. So this is 8 times as many blocks, or 8 times the volume of this original one, because the scale factor was 2. All right, we'll do that practice set when we get into class. All right, now let's look at, well, that'll be one day. The next day, we're going to be looking at lesson 92 and 93. So areas of rectangles with variable dimensions and products of binomials. So again, if we have 3 feet by 6 inches, we can convert it all to inches or all to feet. That wouldn't be too difficult to do, and then find our area. Or we could keep it as is, and we have 3 feet by 3 feet, and then we have 6 inches, or half a foot by 6 inches, and we can do it this way, and then count up how many full tiles and partial tiles we have to come up with the area. So if we have this one, 2.5 times 4 1/4, we could do 2 times 4, and then 1/4 times 1/2, and do it that way. Again, if I'm doing this, what I would do is I would convert this to improper fractions and then multiply them. Since it's not 2 feet 6 inches, it's saying 2.5 feet. We don't need to convert to feet or to inches. It's already in feet, so we'll just leave it as that. So this becomes 5/2. This becomes 17/4. We're multiplying length times width to get those. We get 85/8 as we multiply numerator and denominator. Now, if I said I need 85/8 of something, you'd say, huh? So let's go ahead and convert it to an improper fraction, back from an improper fraction into a mixed number. 8 goes into 85 10 times, which is 80, so we have 5 left over. So 10 5/8. Okay. So you can do it, the 2 times 4 plus the 2 times 1/4, 1/2 times 4, and 1/2 times 1/2. Again, I think since we've been working with mixed numbers since the beginning of the year, I think let's just convert it to improper fractions and then multiply. But again, if you're more visual than me and this one really makes sense and the way I just showed it doesn't make as much sense, you can do it this way by all means. As long as we arrive at the same answer, we know we did it correctly. Okay, and this kind of helps introduce the multiplication of binomials. So a binomial, again, 2 terms, 2 terms. If I'm multiplying x plus 2 times x plus 3, I can use this area method to come up with the solution, which it's going to end up being a trinomial. So x times x x times x, 3 times x, 2 times x, and then 2 times 3. And then we add them all together and we go in descending order like we talked about. Combine like terms in here. We get x squared plus 3x plus 2x becomes 5x plus 6. Now, an easier way and the more efficient way of doing that is what we call FOIL, and it's first, outside, in, last. Okay, so when we have two binomials that we're multiplying, we use the FOIL method. This is the method I use. I prefer. It's easier, it takes less time, so I think it's better all around. If you want to draw out the area method, then you're welcome to do that. It just may take you more time. All right, so we look at our two binomials. Okay, so we've worked with distribution where we have a number or a variable outside and we just multiply it by the 2 in here. But now we have a binomial times a binomial. So I go first, outside, in, last. So FOIL, that's where we get that from. So we multiply x times x times -4, -3 times x, and -3 times -4, which is positive 12. Whenever we multiply these binomials that are laid out like this, we're going to be able to combine these two inner terms. Okay, and then we're done there. It's not set equal to anything, so we're not solving for x. We can't combine any more like terms. We have it in descending order, 2, 1, and then our constant. So we got it there. So that's as far as we can go. And then we'll look at these. I know there's a lot there, so if you want to practice with a few of them, that's fine, but we will do that when we return to class. All right, lesson 93. We're looking at equations with exponents. So we have a quadratic equation, quad 4. If we were to draw this out, it would look like a square. So you guys will do a lot with quadratics as you get into high school. The quadratic formula, parabolas, solving for zeros, and things like that. It's important to note that to this point we've been able to solve for x and we found a solution. Now we're going to run into some scenarios where we have more than one solution. Let's take a look at this one right here, 2x squared plus. Okay, so we won't worry about the exponent right now. We'll just do what we've already been doing. We know how to isolate a variable, think inverse operation. So I'm adding, so I subtract. And I do it to one side, I have to do it to the other. And again, I would write down all your steps. Down the road, you'll have problems that take up, a half or a full sheet of paper. So writing your steps is very, very important. Thinking you're going to keep track of 10 or 15 steps mentally is wishful thinking or just being lazy. Either way, we don't want to do it. Okay, so now we have it here. So I divide. Now we get to this point, and we know we take the square root. Well, square root of 9 is 3, so x equals 3. Yes, that is true. That's not wrong, but it's not the only solution because we're looking back here. So x squared, x to the power of 2, 3 squared is 9, but -3 squared is also 9. So this can be positive or -3. So we can write like that, or x equals 3 or -3, however you want to write it. I just use the two symbols to indicate positive or negative, or we could plug that in for x, even back to our original equation, and work out to be true. So if on a test you just put 3, that's not wrong, but you're going to lose half a point because it's not the only solution. Because of that exponent being 2, and we know positive squared is a positive and negative squared is also a positive, so that's where we get the possibility of 2 solutions. If we have this one here, we divide both sides, and we get x squared equals 8. Take the square roots. And then 4 goes into this, so we're going to write as 2 root 2. And we don't want to write out a decimal number because it's irrational. But 2 root 2, but we could plug in the positive or negative of this into x, and it would work out to be true. So we want to say positive or negative of our solution because that exponent of 2 tells us that there's 2 solutions. And if we have this one right here, we know x can't be 0 because we can't divide by 0, but we multiply, cross multiply, x times x, x squared, 9 times 16 is 144. Take the square root, we know x equals 12, but also negative 12 we can plug in there. Now we don't say the square root of 144 is negative 12 or positive 12, but in this problem, when we plug in 12 or negative 12, it works out to be true. So we need to include both of those solutions. All right, and then if we have a real world example where it's talking about a side length or something like this one we're given the area and asked to find the side length. Take the square root of 100 because it's a square. So we say 10 or negative 10, but in the example of this, we know we can't have a measurement of negative 10 inches. So for this example, we would only come up with a positive solution. So in word problems, just make sure that it makes sense. Like when we've worked with direct variation and we stop at the origin, it's just because a lot of times real world examples, we can't go below 0. We can't have negative of something. So, and this is one of those examples. So we wouldn't say positive or negative 10 inches because that doesn't make sense. We can't have a negative 10-inch side length. Okay, distance is always positive, so 10 inches. All right, we'll do that one together. Practice set, that is it for the week. Thank you guys. We will see you in class. And the camera doesn't even work anyways. I was going to say like and subscribe. But always question, always wonder, all of that good stuff.